everyone, my name is Lucky Chetupoli, and today I will be introducing you to imaginary numbers. To start off, what are imaginary numbers? Well, an imaginary number is a number that has a negative result essentially when squared. You can refer to it when you take the square root of a negative number and it does not have a tangible value. Okay, so when you square real numbers, they will always have a positive product or zero, regardless if the number that is being squared is positive or negative. Say, for example, we take 5 and square it. We would be getting 25. But also say we took negative 5 and squared it. We would still be getting the answer as 25. Our answer was the same whether or not 5 was positive or negative. So, it is inferred that it is impossible to multiply a number by itself to get a negative answer. But now, here's where imaginary numbers come into play. Imagine there was such a number, let's label it I for imaginary, that could be multiplied by itself to achieve a negative product. Let's say I times I equals negative 1. How could this be? Since we have I squared equaling negative 1, to get I, let's take the square root of both sides. Therefore, I would equal square root of negative 1. You may think, what is the point of all of this? Well, imaginary numbers are frequently used in real-world applications. For example, it can be applied to signal processing for cellular and wireless technologies, as well as radar and even brainwaves in biology. So, let's start with an example. What is the square root of negative 4? Well, that could be written as the square root of 4 times negative 1. Also written like this. And that would be equivalent to 2 times, because the square root of 4 is 2, 2 times the square root of negative 1. And we now know that the square root of negative 1 is I for imaginary, so the square root of negative 4 equals 2I. So it's just the square root of positive 4 times I. So from this problem, we can derive a general equation saying the square root of negative x would just equal I times the square root of positive x. Now let's take a different type of problem. Let's say, what is 12I squared? Well, we know that something squared is that number multiplied by itself, so this would equal 12I times 12i. We can also write this as 12 times 12 times I times I. And that would equal to 144 times I squared. Well, we know that I squared is -1, as we previously derived that, so we can rewrite this as 144 times -1. So from multiplying 144 times -1, we would get -144. So 12i squared simply equals -144. So we started with an imaginary number and ended with the real number as the solution. Furthermore, the imaginary number I actually has this really cool property where it basically cycles through 4 different values each time we multiply. So basically I, or I to the first power, the standard, equals the square root of -1. Now I squared, or I times I, equals -1 because, as we said earlier, that would be the square root of -1 times the square root of -1, and you could cross out the square root, so we would just get -1. My bad. Now I cubed would be I squared times I, so that would just be -1 times I. -I, because -1 times I is -I. Now I to the 4th would just be I cubed times I, and we know that I cubed is -I times I, which would be the negative square root of -1 times the square root of -1, which would equal +1. And from here, the cycle just repeats itself. So for I to the 5th power, it would just be 1 times I, which would be the square root of -1 again. So yeah, it's really cool how it just cycles every 4 times. This way, if you wanted to find out what I to a high power would equal to, you can do this in a very simple technique. So say let's take I to the 64th power. That would just be simplified to I to the 8th squared, being I to the 4th times I to the 4th squared, which could be more simplified into 1 times 1 squared, because we know I to the 4th is 1, and so now we know that I to the 64th power would just equal 1, because 1 times 1 squared is 1. So maybe now you could understand silly jokes like this, because you initially might have thought it said square root of -1, heart math, but now you know that the square root of -1 equals I, so this joke says I love math. How funny. Thank you for listening to my presentation about imaginary numbers. I hope you now understand the meaning of what imaginary numbers are and how to apply them.